What is this?
About how
It's my number count.
So you're skip counting for the eighths? Okay. Are you doing the same thing with this one then? Okay.
I did it by hand.
Where did you write it down?
No.
Okay. So when Chloe skip counted up here, where did she stop?
Oh. I was here for that. She stopped at.
When Chloe was skip counting, why did she stop at 60?
Because that was the least common, or the minimal common thing, multiple.
That was a common multiple. That was the first common multiple she came to. So that would be the minimum, the least. Okay. So can we apply that same concept
Yeah.
to what we're doing here? Okay. So what would be? Okay. So skip count.
So what are we skip counting by then?
What are we skip counting by? What?
Sixes?
Sixes and eights. Yes.
So then the bottom of the denominator?
Yes.
So we're counting by the numbers of the denominator. So we'll have two sets of numbers, right?
Yes.
So what are we going up to 60, right?
Maybe not though. We stopped at 60 with 10 and 12 because that was the first number they had in common.
Okay. So we
We
gotta
don't
get
have
a
10.
number that they have in common.
Yes.
Common.
We need to find a common multiple.
Okay. So if we count by 6 is 6, 12.
You might want to write it down. It's going to be helpful to see it.
6, 12,
I'm coming.
18. What do y'all want to stop at?
Because I want to make sure that we're all on the same kind of pathway. So, how does the math that we did in part 1 help us to figure out where to start with part 2? How is the math that we did in part 1 help us to figure out where to start with part 2? Tavari?
It's the multiplication.
It's the multiplication. What do you mean by that? Tell me
It's
more.
like, because it's 10 papers and it's 10 it's packages and I see 10 and 12.
Okay.
So I think they're going to count and to find a common number. And then we have the denominators of the two bottoms is going to be two sets of papers. Well, not papers, but the mirrors, 8 and 6. And we got to count to the most commonest number.
So we have to find a common number between, what'd you say?
My table decided to go to 24 because 8 times 3 equals 24.
How'd you get there though? What did you do to get to 24? Amani?
We times it. We skip counted.
Okay, so you started with 8s
Yeah.
and you skip counted 8 what?
8, 16, then 24.
Did you go higher than 24? No, you stopped at 24?
Yeah, we stopped
Okay,
at-
and what was the next one that you did?
And then we did 6 to 24 too.
So what comes after the 6?
12, 18, and then the 24. And that's where we stopped.
I see how it's like the first.
Ah. So what did you figure out here? Table 5. What did you guys figure out here? Anybody?
I forgot what I was going to say.
Okay, Amani, go ahead.
So I said that the 8 only has 3 numbers in it to stop at, and then for the 6 it only has 4 to stop at.
Oh. So what is the 3 and the 4, like how does that help us with this math?
So the 3
Olive,
and the
you can
4.
pipe in too. Naya, you can pipe in too.
Well, the 3, because we got 2 sets of numbers, and the first one is 3, and then the other one is 4. So it took us 4 times to skip count to get to 24 for 6.
So does that mean 6 times 4?
Equals 24. Then we did 8 times 3 equals 24. So the hidden rule is probably by timesing it to get the nearest common number.
Can you say that again louder for everybody to hear, please?
Maybe the hidden rule is probably to find the hidden common number.
The hidden rule is to find the common number.
Yeah.
Okay. So what have we decided now? Our common number should be 24. And we changed our numerator or denominator?
Denominator.
Oh, so we changed our denominator to 24. The one on the bottom. So if our new denominators have to be 24, now what do we do?